or our alpha can be given to us as 0.01. But it's not necessarily all the time that our alpha is given to us. Alpha is the same thing as good day viewers. Today we're going to learn how to get the values for t calculated for t-tests when we want to test our test of significance. As you can see, in this table we have our degrees of freedom, which is on our horizontal axis. It runs from 1 to 1000, and we can see our cumulative probabilities. Then we have our one tail, and you also see our two tail tests when we are testing for one tail test and two tail test. Sometimes our alpha can be given to us as 0.05, or our alpha can be given to us as 0.01. But it's not necessarily all the time that our alpha is given to us. Alpha is the same thing as level of significance. But sometimes you may be giving it as confidence interval. For example, if you are trying to do a test of hypothesis and you are told that your confidence interval is like the amount, to what degree are you certain, is measured in percentage. To what degree are you certain of your test or of your results? It's probably 1 minus alpha. This is your confidence interval. In the table, as you can see here, it's given to you as your confidence level. You have 0%, you have 50%, you have 60%, all the way to 99.9%. Now, if you are given a confidence level of 0.95%, it means that to obtain your level of significance, you simply say 100 minus 95, 100% minus 95%. That is the same thing as 100 minus 0.95. That is the same thing as 100 minus 95%. That is going to give us 5%. So that is going to give us a 0.05 level of significance. Now, what if you are given 99%? That is going to be 100% minus 99%. That is going to be 100 minus 99. That is going to give you 1%. That is going to give you 0.01 level of significance. Now, let's go to what we call our t-tabulated. Our t-tabulated is usually given to us in this form: t of alpha, then n minus 1. This is when you have a left tail test or you have a right tail test. You have t of alpha n minus 1. As you can see in this table here, it's the same thing as one tail. So, for example, let's go straight to an example. If we are asked to find t of, let's say, our alpha, which is our level of significance, is 0.01, then our degrees of freedom is given to us as 13. So we go to our table, we go to one tail, then we look for 0.01. This is 0.5, 0.25, 0.2, 0.15, 0.1, 0.05, 0.025. This is 0.01. Then our degrees of freedom, we go to 13. Then we trace it to where they connect. It connects right here. That is 2.650. So that means the value of our t-tabulated, is 2.650. Now, let's look at one more example. Now, let's say we are given T of 0.053. Obtain your T tabulated. You go to 0.05, which is in the square box in this case. Then you check your degrees of freedom, which is 3. Then you trace them to where they meet, which is 2.352. 2.353 right here in the table. So that is 2.353. Now, for a two-day test, your t-tab, it can also be written as t-tab. You can see it in some places as t-tab. Is t of alpha over 2 n minus 1. It means that when you've been given your alpha, that is your level of significance, you are going to divide it by 2. So let's say our alpha is given to us as 0.05 here. So we take our calculator and say 0.05 divided by 2. That is 0.025. So that means that our t tabulated is 0.025, comma, let's say n. Our number of observation is given to us as 16. So that means that 16 minus 1 is 15. So we go to where 0.025 is here. So we go to our two-day test. Now take note that for our two-day test, we don't have to check for the divided value after we've divided our alpha. We use the original value. The two-day test is already assuming that it's two-tailed. So you don't have to check for 0.025. Just use the original value given to you. So you use 0.05 and check it under 15. 0.05 under 15, that is 2.131. That is going to be equal to 2.131. But if you are to write it out, you write it out in this way. But when you are checking the table, you don't necessarily look for 0.025. You use the original value given to you. Okay, let's look at one more example. Alpha is given to you as 0.01 and our number of observations is given to us as 14. That means our t of alpha over 2, comma, n minus 1 is same thing as t, then 0.01 divided by 2 is 0.005, comma, 13. So we check 0.01, which is right here. Then we check it under 14. That is 2.977. That is 2.977. And that is how to use our t-table.
Hello everyone! I trust you found this lesson from Academy X helpful and insightful. This is just a glimpse of what we're prepared for you. Inside the full Academy X course, you get access to every lecture, solved examples, quizzes, and study resources you need to excel in this subject. To unlock your complete learning experience, simply click the link in the description below. Join us at Academy X, where we bridge the gap between knowing and truly understanding. See you inside the full course.